Running notes is very simple, very quickly it can be completed. So now just see here, we have completed the entire topic. So this is the last part. They are said to be in phase. Now all these things, little everything is same as it is as we have seen. Rough columns also must be taken there because they are useful for understanding. So just a moment, please. I'll just separate them. Now just see this here. This is the phase difference equation. So this is the okay. So whenever the phase difference happens to be this, they are said to be in phase. This is called as condition for in phase. Two quantities to be in phase. This is called as condition for in phase. Okay, just a moment, please. Just remember them. Then they are not required in the notes. This is the terminology. That's the regular terminology. So they are said to be in phase. Just remember this. So phases. So this is called as the phase of the EMF phi 1. The phase of the current is phi 2. Both are same. We can see that's why the phase difference is coming to be 0 here. So this is the regular terminology. Now to write this in short. So it's very simple. So we'll just come back here. So very quickly we'll complete the running notes. Within 5 minutes it can be written. Okay, we'll come to the first thing here. Now just see here. Now definition AC circuit. This is not important for marks, but still definitions are something like for any person related to science and technology, science and engineering. Definitions are the most powerful things. However simple it is, it can't be taken lightly. What is a AC circuit? It is a circuit. In short, it can be written containing an AC source. That means alternating current source. It also means alternating voltage source. It's also called as AC voltage source. Actually, AC voltage source is not, doesn't have any meaning at all. Alternating voltage source. So it's alternating is difficult to write, so it's written as AC voltage source. That's why it's also called as alternating current voltage source. Also, it's actually meaningless. Actually, alternating current voltage source. So it's unnecessary extra word. So alternating voltage source, but it's difficult to write. Writing is difficult. That's why it's written as AC voltage source. That's why it's also called as alternating current voltage source also, though there is not much extra meaning there. So AC source or AC voltage source. That's the simple meaning of AC circuit. Now the important thing here is the symbol for AC source. This is a symbol, very simple symbol. Now this is rough column actually. Put this in rough column. Compulsory take the rough column also for understanding. Now this is also another part of the rough column. So this actually is a real situation where current flows from a positive potential conductor to a negative potential conductor when they're joined by a wire. So any doubt is there, these are the real scientific situations from which many quantities are defined, especially this diagram, second diagram. It doesn't appear to be very big complicated, but it's very simple and very powerful. Any doubt comes in the real circuits, this only will be helping. They are real scientific situations from which many things are defined actually. So its importance may not be visible now. Later in certain topics really they can be seen. Now coming to the actual topic now, expression for alternating AC current in resistor applied. So this, now most of the equations are same, all the equations will be same as it is. Here also rough column is very useful, though already if you already listen to the AC generator, these things are not required, but still to have some any doubt is there, this will be helpful. So you can take this also in the rough column, in your actual rough column of the classwork. So I said many times, because every complicated problem actually depends upon the theory of the derivation, the actual steps in the derivation. Many complicated problems are like that, and the number of problems or number of complicated problems which can be actually given from a derivation will be infinity. Because if you know the derivation, any problem out of these infinite problems can be done easily if you know the derivation. If you don't know the derivation, even if you solve 99% of the infinite problems, it's not possible. 99% of infinity is also infinity only. Even if you solve 99% of infinity problems, the next problem it's not possible to solve, because if you don't know the derivation. So there is no use in solving problems without derivations. If you are knowing the derivation, if you are learning the derivations and practicing the derivations thoroughly again and again, just 10 problems are sufficient, exactly speaking. Even 100 problems need not be done. 10 problems are sufficient. So that's the power of derivations or scientific derivations. So expression for so okay, coming back. So the running notes here is very simple. So just start. Just two lines will be coming here. So it starts like this. So running notes as I am writing immediately you have to take down. So don't think that I'll take later, because again once a topic is, once you are listening to a particular topic, once you are listening to a particular, watching a particular video class of a class, second time you should not be watching that again. It's time waste, because the classes are lengthy. Each and every detail of a derivation has to be done clearly. Means the class will become lengthy. So only once it has to be listened, and immediately within 5 minutes of that class you should be completing the running notes. Next time always you should be revising your running notes. One page only will be there in that. Nothing will be there. Only one page. In that only all the details, because each and every step of the rough column you are taking. So you not listen to the class again and again. So next time when you are revising from your running notes, within 2 minutes you can revise everything. That's the importance of completing the running notes at the same time. So you should not, because the running notes actually I am giving from different textbooks. So again you need not follow any running note, any notes from any other textbook. You need not prepare. Once you are listening to the class, you are completing the running notes means your preparation is also completed. Whatever you are writing at the same time, within 5 minutes you can study it. Supposing you want to prepare notes from something, another textbook, it will take a lot of time. That is all not necessary. But you complete this now and then refer any textbook for the sake of reference. You can just see that each and every point is contained in your notes itself. So that's the importance of following a scientific derivation. Each and every step must be obtained from a law, the laws of that lesson and the scientific definitions of that lesson. Then every step will be actually getting covered in that steps of the derivation itself. So okay, so start writing like this. A resistor R is connected to an alternating voltage source of EMFE equal to that's all, immediately equal to this equation comes. What is the reason for this equation? Means AC generator, that need not be written. So now just observe here. Now next is immediately after this equation, Kirchhoff's voltage law must be applied for the loop ABCDA. So for that, just observe here. So I am putting certain things in brackets. Even current also, just see here. Current direction I am keeping in brackets because it should not be indicated. Even the positive terminal here I am keeping in yellow brackets. You see, yellow brackets means it should not be indicated in the examination. So directions should never be considered in the exam. But without directions, the equations can't come. But directions are indicated means it looks like a DC source. That's why directions are not shown, and the polarities of the terminals are also not shown in the actual circuit diagrams of any textbook. So compulsorily you have to avoid the bracketed things, which arrow you have to avoid. Current you have to show because I denotes the current in the circuit. EMF you have to show, but positive, negative, and direction, upward direction should be avoided. But without that, so you put them in with a pen, with a pencil you draw them. Just as I have kept them in yellow color, you draw them with a black pencil because pencil will be very light compared to the pen. So you need not, you can just remember that it is something not to be written in the board exam. And always apply the Kirchhoff's voltage law with the signs only. So that means without considering the polarities, we can't get the equation. So powerful are the polarities. Though it's not, it must be avoided in the board exam. They'll be these polarities only will be really useful in the problems, complicated problems. Okay, now next. So applying, so I'll use the same color again. applying the, see here, KVL for loop ABCDA. So next step is this, sigma V is equal to 0. So all this understood. So as it is, it can be taken. So just wait for a moment, don't write now. So immediately this can be written. So after this, not much notes will be there. So only the first paragraph should be clearly explained, 3 lines, that's all. After that, not much explanation will be there. We'll just see the next page once. Next page is this, just see here. So next is here, this step, no explanation you see. Directly it can be written. So potential difference across R, everything is clear. So 3 dash, next 3 in 3 dash, substituting. This substituting. Just remember this, substituting 3 in 3 dash will get this result. So after this, just see here, this equation. Now the important thing is all these steps are very powerful steps. So boxes must be drawn. So the boxes, I'll do one thing, I'll draw with the yellow color so that the equations will not be disturbed. This is a very powerful equation. Next this equation. So next this equation, including the first and second equations. So I'll just go back to the this equation also. This equation. They are very powerful equations, including the signs plus and minus. Remembering this, all the equations, you also can draw them pencil so that the that page will not be looking congested. So if you are using pencil, means the page will not be less number of lines, thick lines will be there. So I will not be, it will become, the page doesn't appear to be congested. Okay, these are the equations. So as it is taken, all the steps can be taken, no change at all. Now here little matter will be there. So this matter, just once listen to this matter, what to be written. Hence the peak current I naught. Next, peak voltage. So there's no place here. I'll just put peak voltage V naught and R, obey Ohm's law. What is the Ohm's law means? Here we can just see. This is very important. Very important fact. So all the equations are very important here. All the results here. So what is here? V is the potential difference or voltage. Potential difference is also called as what? Voltage across R. Each and every word is very important here. So next, this one. So what is this explanation for this? Nothing but a graph is drawn. Okay, actually there's no place here. So next here, next part here is a graph. Here I am writing a graph is drawn. This explanation, this particular line has come even in the AC generator also. Taking EMF or voltage on y-axis and time t taken on x-axis. So now from, not much explanation is required here because already the entire explanation has come previously in the previous AC generator itself. Here again it's not required, just indicated graph is drawn. It is as shown, all that details are not required. Taken time t on E or V on y-axis. Not just E or V and time t, even current also can be taken on y-axis. So that can be indicated here. Actually there is no place here, so I'll try to write it as clearly as possible. E or V and I on y-axis. So I am putting in bracket. That means either E can be taken or I can be taken. That's the meaning. E is same as V. So or V is I kept here. Again or I am not using, and I kept. So to show that it's a separate graph, I kept this in square brackets. That's the purpose. So it's very simple. No complication is there in understanding this one. So now from very important equations 3 dash, from 3 dash and 4, the phases of V and I can be seen to be same. That's the purpose of 3 dash and 4. But there's no place here. I'm just continuing it in the next class, next page. Just remember this. This is not difficult to understand. So when you're writing the running notes from the first page, all the steps can be taken. So from 3 dash and 4 dash, from 3 dash and 4, this is 3 dash. Just see here. This is 3 dash and 4. That is what I have written here. Just remember this. From 3 dash and 4. So next page I'm just continuing this here. So don't write now, just listen. So 3 dash and 4, it can be seen that V and I become maximum or minimum at the same time. Therefore, the phases of V and I are same at any time equal to omega t for a resistor. This is a very considered to be a very important result. So this is also kept in brackets. For a resistor. So I'm just removing this in phase word here. So it comes actually as the next point. So there's not complication here. So very easily this point can be taken. So this is the next point. So actually there is no place here. So I'll go to another page. I've taken another page. Therefore, again, so phases are same equal to omega t. That's what we have seen. Just see here. Equal to omega t. So that means, okay, there is some space here. So here itself I'll try to write. So that implies so I'm just using the same color, blue color. The phase difference between V and I at any t means time, is 0 for a resistor. So all the things which we are considering only for a resistor, we are saying V and I are the potential difference and current. The phase difference between potential difference and current is coming as 0 for a resistor. Only resistor. That means we are not considering any other component like capacitor or inductor. So all the results which we are getting are applicable only for a resistor. That's very important here. So I'm just again putting a box. This is also considered very important. So this is important. This is important. So next, now we'll go to the next page. Therefore, V and I are in phase for a resistor at any time t. In phase means, what is the meaning? Why it's called as in phase? Because whenever the phase difference happens to be either 0 or 2 pi or 4 pi, they are said to be in phase. This is the completion of the entire answer, entire topic. So this is the completion of the topic. So with this, that, so what is in phase? Already we have seen the meaning of in phase. So though I did not give this separately, this is the meaning. Whenever phase difference is 0, 2 pi, 4 pi, 8 pi, or that is 2n pi, that's said to be in phase. But this comes under rough column. Just see here, rough. So very very important. It's rough. So only in the rough column should be taken. Always the classwork topic, each and every detail is very important, including the rough column, because any problem can be asked in this. However complicated it is, it can never, however complicated a problem is, many times I said, however difficult a problem is, it can never touch or reach the level of a scientific derivation. Scientific derivation is of the highest order. Problems are nothing compared to a scientific derivation. Any problem, though however difficult it is, if it answer doesn't strike the mind, it may take days together, but still it can be obtained from the derivation itself. It can be obtained from the scientific concept itself, however tough it is. But scientific concepts are not easy. Only few concepts are there, discovered by only few scientists. Problems, numeral, infinite problems will be there with more and more difficulty levels. But still, nothing can compare with a scientific derivation. So many problems we have seen that many steps of derivations or topics also we have seen this, and again many more examples will be coming based on this, the importance of a derivation and the importance of a problem. So okay, now coming back to the topic. So this is the completion of the topic. So now everything is in order. Just see here. So this is the first page. So next page, third page, next fourth page. So all this now, very simple manner, the notes can be written. Now you start writing the notes within 5 minutes. Already diagram everything already you have completed. Within 5 minutes you can complete this running notes.